Okay, Assalamualaikum and hi everyone. So in this video, we are going to continue our lesson in chapter 7, Ionic equilibrium. Okay, so for this part, kita akan tengok untuk salt, okay, untuk garam. Jadi kita akan tengok, okay, the learning outcomes for this part is, kita akan explain qualitatively salt hydrolysis using hydrolysis equation and classify the salt form from the reaction between. Okay, so kita akan ada reaction between strong acid and strong base. Okay, then we have acid with salt from strong acid and weak base, and salt from weak acid and strong base. Okay, so what is salt? So salt is an ionic compound that is formed by the reaction of an acid with a base. Okay, so garam merupakan sebatan ionik yang terhasil daripada tindak balas asid dan juga base. So the general equation, okay, untuk neutralization is HX plus MOH produce MX dan juga H2O. So HX is our acid and then MOH is our base. So it will produce MX, which is our salt, and H2O. Okay, so this is the salt that came from, okay, cation is from base and then anion is from acid. Okay, so acid kita ada X, jadi X minus and then M plus. Okay, so M plus dengan X minus combine, dia akan menghasilkan salt. So this is the example of salt. Okay, so kita akan ada, okay, so few example of salts di sini iaitu such as sodium chloride, NH4Cl, okay, ZnCl4, ZnSO4, CH3COONA, and then CH3COO, NH4. Okay, so daripada sini sebenarnya kita boleh tahu, okay, dia datang daripada strong acid, okay, strong base ataupun daripada strong acid dengan weak base, dan daripada strong acid dengan weak acid dengan weak base. Okay, weak acid and weak base. Okay, so salt can be classified as neutral, acidic or basic in aqueous solution as they undergo a process called hydrolysis. Jadi kita nak tahu salt itu bersifat neutral, berasid ataupun berbase, dia daripada satu proses yang kita panggil hydrolysis. Jadi hydrolysis is a chemical reaction between an ion, okay, or cation from a salt with water molecules. So pH of the solution depends on whether OH minus ataupun H plus ions is produced from the hydrolysis reaction. Jadi kita nak tahu pH ni, kita tengok adakah OH minus ataupun H plus ini terhasil daripada proses hydrolysis. Okay, so what is hydrolysis? Okay, what is salt hydrolysis? Okay, so salt hydrolysis is the reaction of an anion or cation or both of salt with water molecules. Jadi salt hydrolysis ni adalah tindak balas, okay, cation ataupun anion daripada garam dengan molekul air. So hydrolysis meaning that reaction with water. Okay, so three types of salt hydrolysis. Kita ada tiga jenis salt hydrolysis, which is salt from strong acid and strong base. Okay, and then salt from strong acid and weak base, and salt from weak acid and strong base. So MX salt dissociate equation, okay, dissociation equation will produce MX produce X minus and M plus. Okay, right. Okay, so cation hydrolysis, okay, for the cation hydrolysis, okay, untuk cation M plus ni, okay, so when we add with water H2O, it will produce MOH and H plus, which is, okay, kalau dia produce MH plus, okay, because dia daripada cation. Cation daripada mana tadi? Daripada from acid, okay. Cation is from acid. Okay, for hydrolysis anion, okay, X minus plus H2O will produce HX and OH minus. Di X minus, okay, X minus ini daripada base, okay. Alright. So type of salt. Okay, kita akan tengok jenis-jenis salt ataupun it is either neutral, acidic ataupun basic. So kalau dia neutral salt, okay, the example is NaCl. So NaCl will produce, okay, from the reaction between strong acid and strong base. So NaOH is a strong base, ACl is strong acid. So the salt dissociation will produce Na plus and Cl minus. Okay, thus dia adalah weak conjugate acid, and then this one is weak conjugate base. So the hydrolysis, okay, both weak conjugate ions do not hydrolyze. Okay, jadi since dia daripada strong base, jadi akan menghasilkan strong base dengan strong acid, dia akan menghasilkan weak conjugate acid and weak conjugate base. Thus dia tidak boleh mengalami hydrolysis. So the pH of the solution depends on the auto ionization of water, which is water will produce, okay, H3O plus and OH minus. So Kw is equal to 1 exponent negative 14. So the concentration of H plus equal to concentration of OH minus equal to 1 exponent negative 7. Thus the pH is equal to negative log 1 exponent negative 7, which is the pH of the solution is 7, which is neutral. Okay, because it is came from strong acid and strong base. Okay, so NaCl is a neutral salt. Next, okay, example we have NH4Cl. NH4Cl came from ammonia and hydrochloric acid. So ammonia and hydrochloric acid is from ammonium chloride. So ammonium chloride came from weak base. Ammonia is a weak base. HCl is a strong acid. Thus, okay, the dissociation of the salt will produce NH4 plus aqueous and Cl minus aqueous. Okay, so yang akan mengalami hydrolysis, okay, ini daripada strong conjugate acid, okay, because dia daripada weak base just now, okay. Jadi kalau dia daripada weak base, dia akan menghasilkan strong conjugate acid. Jadi yang ini adalah weak conjugate base sebab dia daripada strong acid. Jadi yang mengalami hydrolysis, okay, dia undergoes hydrolysis, okay, NH4 plus, okay, daripada strong conjugate acid, and it undergoes hydrolysis with H2O. So it will produce ammonia and H3O plus. Thus H3O plus is present. Jadi kalau H3O plus yang ada, maksudnya salt dia, okay, pH of the solution yang terhasil ini kurang daripada, must be less than 7. So therefore NH4Cl is an acidic salt. Okay, alright. Next, we have sodium carbonate. So sodium carbonate, okay, the formation of sodium carbonate is from carbonic acid H2CO3, okay, and NaOH, which is sodium carbonate. So H2CO3 is weak acid and NaOH is strong base. Jadi dia akan menghasilkan, it will produce, okay, salt Na2CO3. Jadi CO3 itu minus daripada weak acid. So dia merupakan strong conjugate base. And then this one is weak conjugate acid. Okay, alright. Tadi yang akan undergo hydrolysis is they came from strong conjugate base. Jadi kalau strong conjugate base ini undergoes hydrolysis, it will produce HCO3 minus and OH minus. Jadi OH minus yang present, since OH minus is present, the pH of solution more than 7, which is basic. Okay, therefore Na2CO3 is basic salt. Okay, another example. We have sodium cyanide, NaCl is a salt form from strong base is react with weak acid ACN. So write a balanced equation to show the reaction between NaOH and ACN. Classify the salt form. What would be expected of pH when NaCl solution, and explain okay, using equation. Right. So first of all, the equation is between NaOH and ACN. So NaOH is a strong base, and then ACN daripada weak acid. So kita dapat NaCN, salt. Okay, this is our salt. Jadi salt ini NaCN dia akan dissociate kepada Na plus dan juga Cn minus. So Na plus daripada strong base, jadi dekat sini dia adalah okay, weak conjugate acid. This one dia adalah strong conjugate base. Jadi yang akan undergo hydrolysis adalah Cn minus. Okay, so Na plus is a conjugate acid of strong base. Okay, and then dia tidak mengalami hydrolysis. Cn minus is conjugate of weak acid. Jadi dia merupakan strong conjugate base. Okay, so Cn minus will hydrolyze in water. Okay, Cn minus yang akan mengalami hydrolysis in water. So Cn minus plus H2O will produce OH minus dan ACN. So the solution is basic because the hydrolysis of Cn minus produce OH minus. pH of the basic salt is greater than 7. Jadi kalau dia greater than 7, maksudnya dia adalah basic salt. Alright, so tengok another exercise. Okay, CH3 and H3Cl is a salt formed when a weak base, okay, react with strong acid, HCl. Okay, write a balanced equation to show the reaction between CH3NH2 and HCl. Classify the salt form. Okay, what would be expected pH of the CH3 and H3Cl solution? Explain the answer using equation. Okay, so first write the equation between strong acid dengan weak base. So this one is our strong acid, and then this is our weak base. Okay, and then we will produce CH3 and H3Cl. Jadi CH3 and H3Cl dia akan dissociate kepada ion CH3 and H3 plus dengan Cl minus. Okay, Cl minus is anion of strong acid. Sebab dia daripada strong acid tadi. Okay, jadi dia merupakan conjugate. Okay, conjugate base yang lemah. Jadi dia tidak mengalami hydrolysis. Yang akan undergo hydrolysis is CH3 and H3 plus. Okay, jadi bila dia akan mengalami hydrolysis plus water, okay, it will produce H3O plus. Thus the solution is acidic because hydrolysis of CH3 and H3 plus will produce H3O plus. So pH of the acidic salt solution is less than 7. Okay, alright, next kita akan tengok exercise, okay, for the given salt. Okay, write the equation for the formation of salt, dissociation or ionization of the salt, and hydrolysis of the salts. So determine the type of salt. It is whether acidic, basic, okay, ataupun neutral salt. Okay. Alright, next kita tengok buffer solution. Okay, so at the end of this lesson, okay, students should be able to define buffer solution and write the Henderson Hasselbalch equation for a given buffer solution. So what is a buffer solution? Okay, buffer solution is a solution that has the ability to maintain its pH when a small amount of strong acid or strong base is added to the solution. Okay, and then the example of buffer solution is seawater, pH greater than 7, okay, and then fluid for injection. Okay, so fluid for injection, pH dia adalah 4 to 8. So ini adalah example of buffer solution. So buffer solution are important in biochemical and physiological processes. Okay, this is because organisms and humans have a built-in buffer to protect them against changes in pH. So the pH blood is 7.4. Jadi if the pH is less than 7, ataupun greater than 7.8, okay, kita akan mati. Okay, this is because human blood is maintained by combination of CO3 2 minus, okay, and PO4 3 minus, and protein buffer. So human blood is a buffer solution. So kita ada dua jenis buffer solution, which is acidic buffer solution, which is pH dia mesti kurang daripada 7, okay, pH less than 7. So acidic buffer solution contains a weak acid and a salt of its conjugate base. And the basic buffer solution, okay, pH dia lebih besar daripada 7, greater than 7, because dia adalah basic buffer solution. Jadi basic buffer solution dia mengandungi a weak base and, okay, salt of its conjugate acid. Okay, so the example of acidic buffer solution. So we have this acetic acid. Okay, acetic acid adalah weak acid, and then sodium ethanoate is conjugate base. Okay, dia daripada weak acid tadi, garam. Dan bila kita masukkan dekat dalam buffer solution, okay, kita campurkan kedua ni, dia akan jadi acidic buffer solution. Next, example of basic buffer solution. Okay, example of basic buffer solution: ammonia, weak base, and ammonium chloride. So ammonium chloride is conjugate acid. Jadi kalau dia conjugate acid, dia sebenarnya adalah garam daripada ammonia. Okay, so it will produce basic buffer solution. Okay, unbuffered solution. Okay, unbuffered solution initially, okay, 5 pH. And then bila kita masukkan okay, sedikit asid, dia akan, okay, turun kepada 2. And then kalau kita masukkan base, dia akan naik pergi 12. Sebab apa? Sebab dia tiada buffer effect. Okay, right. So kalau kita masukkan buffer, okay, initially pH dia adalah 5. When we add some acid, it will drop to 4.8, sangat sedikit. And then when we add NaOH ataupun base, it will increase dalam kadar yang sangat sedikit. Okay, so now, okay, which of the following pairs constitute a buffer? Okay, mana akan menghasilkan buffer? Right, so kita ada HNO2 dan juga NaNO2, NaOH dan NaCl, HNO3 dengan NH4NO3, NaCl and KCl. So NaOH is a strong base, and ACl and HNO3 are strong acid, hence they cannot use as buffers. Okay, untuk B, okay, dia adalah strong base, NaOH, jadi tak boleh lah. Okay, and HNO3 pun strong acid, jadi dia tak boleh jadi buffer. Okay, ACl strong acid, jadi tak boleh jadi buffer solution. Jadi yang jadi buffer cuma A. Okay, HNO2 adalah weak acid, NaNO2 salt daripada combination weak acid dan juga strong base. Okay, bagaimana buffer solution, okay, bertindak balas? Okay, how the buffer solution works? Okay, the example, acidic buffer solution. Let's consider acidic buffer, which is composed of weak acid HA dan juga salt dia. Okay, Ma, di mana M plus would be Na plus ataupun K plus or any other cation that does not react with water. The acid dissociation equilibrium in this buffer solution involves both acids and its conjugate base, which is HA aqueous produce HA plus, H plus aqueous and A minus aqueous. The corresponding acid dissociation constant expression is Ka is equal to H plus times concentration of A minus and HA. Jadi solving the Ka expression untuk H plus, Jadi kita akan letakkan H plus sebagai perkara rumus kita. So concentration of H plus equal to Ka times concentration Ha over Ka over A minus. Thus the pH are determined by two factors. Okay, kita ada dua factors which is okay, Ka for the weak acid, the value of Ka for the weak acid, which is the ratio of the concentration of the conjugate acid-base pairs, which is concentration Ha over concentration A minus. If OH minus is added, jadi kalau kita masukkan OH minus, they react with buffer acid component to produce water and A minus. Jadi OH minus ini dia akan bertindak balas dengan weak acid. Okay, sebab OH minus adalah base. Jadi base akan bertindak balas dengan acid. This neutralization reaction causes concentration of Ha to decrease and concentration of A minus to increase. As long as the amount of Ha and A minus in the buffer are relatively large to the amount of OH minus added, the ratio of Ha over A minus does not change much. Therefore, the change in pH is very small. Okay, right. So if H plus is added, H plus is acid. Jadi acid dia akan bertindak balas dengan the base component of the buffer solution adalah A minus. Jadi A minus will react with H plus and produce Ha. This neutralization reaction causes concentration of A minus to decrease and Ha to increase. Jadi concentration of Ha akan increase as long as the amounts of Ha and A minus in the buffer are relatively large to the amount of H plus added. Jadi the ratio of Ha, concentration Ha over concentration of A minus does not change much. Jadi kalau tiada perubahan yang banyak, therefore the change in pH is very small. Okay, alright. So kita tengok acidic buffer solution. This is the example of acidic buffer solution. Okay, acetic acid, okay, CH COOH and sodium ethanol. Reaction that occurs in the buffer solution. Apa yang berlaku di dalam buffer solution? Okay, acetic acid dia akan partially dissociate and produce CH COO minus and H plus. Jadi weak acid akan produce conjugate base. Then CH COO and A undergoes complete dissociation. Jadi kalau dia undergoes complete dissociation, it will produce CH COO minus dan juga Na plus. Jadi salt dan juga conjugate base. According to the Chatelier principle, the presence of large amount of acetate ion reduce the dissociation of CH COOH, okay, acetic acid. Jadi acetic acid dia akan dissociate kepada H plus dan juga CH COO minus. So the species presents in large amount is the undissociated, okay, CH COOH and the CH COO minus ion, which come from the complete dissociation of CH COO and A. Okay, so species yang ada dekat dalam buffer solution ni adalah, okay, is a weak acid CH COOH and conjugate base CH COO minus. So H plus dan juga Na plus pun ada dalam ni. Jadi action of acidic buffer solution. So bila kita masukkan small amount of acid, okay, acid akan bertindak balas dengan weak base, okay, conjugate base. Okay, ini daripada salt tadi. Okay, so dia akan bertindak balas dengan H plus dan menghasilkan weak acid semula. Since the dissociation of CH COOH is negligible, which is very small, the pH is maintained. Okay, alright. So bila kita masukkan base pula, okay, base ni adalah CH COOH dia akan bertindak balas dengan OH minus ion dan menghasilkan H2O dan juga CH COO minus ion. Jadi CH COOH dan AOH minus yang kita tambah tadi, dia akan produce CH COO minus dan juga H2O. Jadi OH ni adalah base. Jadi base dia akan mencari apa? Dia akan bertindak balas dengan acid. Jadi bila dia bertindak balas dengan acid, dia dapat CH COO minus. thus the pH is maintained. Okay, alright. So kalau acetic acid dan juga acetate buffer works, bagaimana pula acetic acid dan juga acid? Okay, buffer with equal concentration of weak acid and its conjugate base. Jadi H3O+, okay, bila kita masukkan H3O+, dia akan bertindak balas dengan CH COO-. Jadi concentration CH COO- akan berkurangan sedikit dan CH COOH akan meningkat. Sebab H3O+ ni dia akan bertindak balas dengan CH COOH dan menghasilkan CH COOH. Okay, alright. So concentration dia akan berkurangan. Okay, kalau kita masukkan OH-, OH- adalah base. Jadi base ni dia akan bertindak balas dengan CH COOH. Jadi acetic acid kita akan berkurangan dan acetate ion bertambah. Okay, tapi pH dia tidak banyak berubah. So HA scavenges OH-, AS- scavenges H+. Okay, basic buffer solution. Okay, untuk basic buffer solution, the example kita gunakan ammonia dengan ammonium chloride. So reaction yang occur di dalam buffer solution is ammonia is partially dissociate. Bila ammonia partially dissociate in water, it will produce NH4+ dengan OH-. Okay, NH4+ dia akan undergoes complete dissociation and will produce NH4+ dan juga Cl-. Okay, ammonium chloride akan putus kepada, okay, dia akan dissociate kepada NH4+ dan juga Cl-. Jadi dia adalah salt dan juga conjugate acid. So the effect dia sama dengan acidic buffer solution. Bila according to early Chatelier principle, okay, the presence of amount of NH4+ reduce the dissociation of NH3. The NH3 and H2O will produce NH4+ and OH-. Okay, so the species present in large amount is the undissociated ammonia and NH4+ ion, which come from the complete dissociation of NH4Cl. Jadi, the species present in this buffer solution is ammonia sebagai weak base, ammonium ion, iaitu conjugate acid, NH4+ dan juga OH- dan juga Cl-. The action of basic buffer solution. Okay, kesan-kesan basic buffer solution. When a small amount of acid is added, okay, bila kita masukkan acid, okay, weak base will react with the added H+ ion to form NH4+. Jadi bila kita masukkan H+, H+ ni adalah acid. Jadi acid dia akan bertindak balaskan dengan base. Base ni adalah weak base. Jadi kita dapat apa? NH4+. Thus the pH is maintained. Okay, kalau action of basic buffer solution, bila kita masukkan, okay, sedikit base iaitu OH-, NH4+ yang akan bertindak balas. Sebab NH4+ adalah, okay, daripada NH4+ adalah acid, conjugate acid. OH- is strong base. Jadi NH4+, okay, plus OH- diproduce NH3 aqueous dan juga H2O liquid. Jadi since the dissociation of NH3 is negligible, sebabkan Kb sangat kecil, jadi pH akan maintain. Okay, so the pH untuk buffer solution kita gunakan Henderson Hasselbalch equation. Kalau untuk acidic buffer solution, pH is equal to pKa plus log conjugate base over weak acid. Ataupun kat sini selalu kita boleh juga tuliskan dia sebagai salt. Okay, concentration of salt over weak acid. And then kalau untuk basic buffer solution pula, dia adalah POH plus equal to pKa plus log conjugate acid over weak base. Okay, so this is the equation. Alright, so we have this example. Okay, let's say we are going to calculate the pH of a solution containing 0.2 molar HF dan juga 0.4 molar NaF. Okay, given Ka untuk HF adalah 6.6 exponent negative 4 mol per cubic decimeter. So pH is equal to pKa plus log concentration conjugate base over weak acid. Jadi kita ambil je conjugate base tadi, iaitu 0.4 over 0.2. Okay, negative log 6.6 exponent negative 4. Jadi pH dia sama dengan 3.48. Okay, alright. Ini adalah pH untuk buffer solution. Alright, so that's all for our lesson in lecture. Thank you, class.